radio access networks are expected to drive quick adoption of 5G, but operators remain challenged by legacy equipment still in play.
5G will be in existence for many years while your cell phone device will still be able to access the LTE network, the 4G network. So there's that coexistence problem.
Here's how a distributed edge cloud architecture can change that.
In some cases, the ability to support a new modernized 4G application at the edge of the network that runs that radio infrastructure coexistent with the 5G application is important. In other cases, we're simply placing new equipment and capabilities right next to the legacy 4G equipment and maintaining them both at the same time. It's really very dependent on the service provider's unique network needs. O-RAN really represents, from a interface standardization perspective as well as a software-based perspective, the opening up of all these interfaces the way that a software project normally succeeds.
Paul Miller is the CTO of Wind River, a company playing a key role in bringing distributed edge cloud architectures to market. Paul, thanks for joining me today. Let's first talk about Wind River and the solutions it's bringing to market to develop O-RAN.
Yeah, thanks, Diana. In O-RAN, we're very active in the O-RAN Alliance in Workgroup 6, which is the cloudification and orchestration component. In particular, we've made an investment that's culminated over the last 3 years of work in an open source activity called Starling X, which we co-founded with other industry members such as Intel in the Open Infrastructure Foundation. And that Starling X technology is a distributed Kubernetes platform that enables cloud-native services to be deployed over a geo-distributed system. And you're going to have an incredible number of wireless RF stations deployed. So that means possibly 10x more RF stations than you have with something like 4G. So as we looked at that problem at our company at Wind River, we introduced a new technology based on Starling X from the open source community called the Studio Cloud Platform. And what that does is looks at the cloudification of that distributed system as a new and interesting challenge. Obviously, if you have a highly distributed cloud, that creates a new set of requirements different than what we used to have with NFV. Now you're trying to run a cloud across thousands of separated sites. At each site, you have to have an incredibly small footprint in order to be cost effective. So that is the fundamental reason why we founded the Starling X initiative, is to embrace those new requirements that the distributed O-RAN system has. And in doing so, came up with a variety of different attributes that are proving to be very valuable to the deployment of O-RAN. So, for example, the ability to fit down into a single server node footprint at the edge and still have the full functionality of a distributed cloud, the zero-touch deployment, a single pane of glass to manage that entire environment, a very high-performance Linux system underneath it to enable the real-time application of the VDU to function properly. We've also had, as we worked on that technology, a lot of great partnerships with industry providers in this solution. Samsung is a great example where we've worked for several years now in deployment, actual live deployment at Verizon with a fully vRAN-based solution, and also an incredible partner, Intel, as we've worked together on the de facto standard for the platform that these systems run on, the Intel Xeon, as well as a lot of Intel technology on high-performance network interfaces, NIC cards, as well as intelligent I/O. So when you wrap up everything I just said, you can see that the vRAN problem, distributed 5G and O-RAN, it's fundamentally different than cloud technologies that we had previously, and it requires partnership with key industry players to succeed in that space, but also a completely different approach to the way you build a distributed Kubernetes system.
Interesting. And how can service providers innovate more with this type of cloud-based architecture? What kind of applications are now available to them?
It's much like a very modern Google environment where they have the flexibility to deploy services at a whim, right? Within days, you can deploy a new service through a virtualized network. This is now really opening the eyes of the service provider that a lot of new business is possible by having a fully virtualized environment. They can deploy multi-access edge compute applications anywhere in their network, all the way down to the edge. If we talk about a simple application like, or simple I should say, but autonomous vehicles doing vehicle-to-vehicle accident avoidance, or V2V, there's an ultra-low latency connection required between those two cars for them to avoid each other, for them to avoid hitting each other on the street. And that requires a low latency 5G connection, but it also requires the service provider to be able to host that application at the edge of the network that's working between those two vehicles. So there's a real need as you think about what the contemporary consumer is expecting for things. We all expect to be able to drive to work in a self-driving car. That's driven by 5G and its capabilities.
And aside from the cloud, what are the other technologies service providers should invest in order to enable those types of use cases?
So beyond the cloud, we also provide, for example, an inbuilt analytics solution, a big data engine that allows us to provide unsurpassed visibility through the core to the edge of the network, and a platform for machine learning so that in this huge amount of data that's coming from thousands of sites, you can perform functions like predictive outage avoidance and predictive analytics on that solution. And then the other piece that we found to be incredibly important is really embracing the concept of automation. So we created an automation framework called the Automated Operations Composer. And that system provides not only Mano functions for orchestration and management of the lifecycle of applications, but also automated deployment of the cloud infrastructure itself and integration with real operational needs that a service provider is challenged with on a day-to-day basis as they try to run their network and touch hardware and configure things. The one thing I would say is very, very different about this transformation is that some incredible OpEx cost efficiency could come out of this. For example, we've seen operators take our technology and deploy it at the edge of the network to host virtualized RAN in a completely lights out blank fashion. There's no operating system on the machines. They're completely off. They're placed at that remote site and then everyone leaves. And as you bring all this together, we think that as we sit here today in 2021, going into 2022, this is really the birth of the deployment of this technology. We're past the proving points. We know it works. We know the business case works. And that's why you're seeing a lot of service provider announcements and traction against the new approach.
Well, Paul, thanks so much for your time today, and thank you all at home for watching. My name is Diana Blass with Current Insight, your host for Leaders In on Open RAN. For more coverage like this, be sure to stick with Light Reading.